So to illustrate the phenomenon of polymerase slippage, I found this piece of velcro in my wife's cupboard. So this piece of velcro could easily represent this two strands of DNA. So let me separate that. All right, so you got your two strands of DNA that obviously separate before the process of DNA replication. So if you have this one strand of DNA, which will serve as a template for DNA replication, and then the other strand will be polymerized in this way. So you first have, your little primer. So you have a little primer here, and you have to imagine. Then you have a DNA polymerase that's going to come in and polymerize this strand. So it's going to go, and you have your double-stranded DNA. Now you have to imagine you have your mother strand of DNA, which is this one. This is the fuzzy one. Okay, that's your mother strand, and then you have to imagine that within your mother strand, Velcro is sticky, pretty much like single-stranded DNA, I guess. Okay, so you have your mother strand here. You have to imagine that here you have your triplet repeats. So you have your repeated DNA over and over. So it's the same sequence repeated, and that's important for the strand slippage phenomenon. Okay, so let's say that now the polymerase comes in and polymerizes these repeats. Okay, let's say the repeats go all the way up to here. So I have pretty much the length of my screen here. Okay, so let's forget this for a moment. You have to ignore this part because this has not been replicated yet. I'll just hide it in my hand like this. Okay, hopefully. All right. Okay, so now you have your piece of replicated DNA. Now remember, this part here is all repeat. So between my two fingers, you have the repeated part of the DNA. So let's just say that once in a while, your DNA polymerase slips or it might fall off, and the two strands of DNA might peel off. This can happen. Once in a while, this can happen. And then, so what happens if the DNA peels off? So you sort of have this unwinding of the DNA, okay? And then the DNA tends to be sticky, just like this Velcro. So it will tend to reassemble together. That's fine. But the problem is, because these regions are repeated, then the DNA might just slip behind, form a loop like this, right? And then this is what happens. So when this loop is formed, this piece of DNA can assemble with the other one. It's complementary to it because it's repeated DNA. It's just the same repeat. So it can just fall back and stick to it. But now what happens here is that you have the end of the DNA is now going to serve as a primer for the next polymerase to come in. And it's going to prime, and it's going to replicate this piece of this piece of DNA again. So it's going to replicate the repeats again. So what's going to happen? Okay, so this happens again. This replicates once more, all the way up to the end of the repeats. So there you go. So what happens here? So now the polymerase has replicated this part again. So we have amplified the repeats in the daughter strand because of this loop. So instead of having from the mother strand this length of DNA with the repeats, or I guess this length here from the base of the repeats, you'd have this length between my two thumbs. So this would be the length of the mother strand, the length that you had in the mother strand, right? So if you flip it over, this is the length that you have in the daughter strand. It's much longer. Let me unwind it to just show you. Obviously, that's quite obvious. It's much longer, right? So this is what you have in the daughter strand. So you have much more of the repeats. So repeats are amplified in this way. So when this daughter strand is going to replicate next in the next generation, then it will give you more of these repeats, and the amplification phenomenon can happen once more. So this is how these triplet repeats can lead to amplification through the slippage of DNA polymerase. Now, the slippage could theoretically happen in the daughter strand, or it could also happen in the mother strand. If it happens in the mother strand, you get the opposite phenomenon. You get a shrinkage of the repeats in the daughter strand. So let's say if you have a loop forming in the mother strand, this happens here, and then polymerase continues. But then in the daughter strand, you'll have a shrinkage of the number of repeats this can also happen as well. So the thing is, the consequence of shrinkage are very less deleterious than the consequence of amplification, because amplification leads to more triplets and more problems, as you might see in my presentation. But it can happen both ways. But we don't really see the consequences of shrinkage. We see the consequences of amplification in the daughter strand.